Hello, and today is our final nail about Datomic pagination. Today I'll introduce you the final algorithm which we use on production and which is smart, fast, short and very usable. Looking deep inside Datomic documentation, you can find out that as opposite to the regular other databases aggregation functions, Datomic implementation has already built-in function which allows you not to find out the only one minimal value, yeah, but take n minimal values of some parameter and returns a set or vector, anyway, returns a collection of n minimal values of parameter which exists in all the query. Yep. And that allows us to implement a Datomic pagination in a very smart and effective way. First of all, as you remember, we use for cursors also an entity IDs for making cursors unique. And that allows us to do the trick. Let me show you. First of all, we will create a simple query where cursor is bigger than starting cursor from, and we will take the minimum n values of cursors. What it would returns. For example, if we query 10 elements of cursors from name 33, we will return this result. And it's quite fast, it's about 55, it doesn't matter, it depends on current current computer actions. Maybe next time it will be, yes, 36 milliseconds, so it's quite fast. But only one point, it returns only cursor values, not entities itself, not other stuff like we can do in previous algorithms. But we can do the trick. As cursor has suffix of ID of entity, we can extract this ID and then map all this list by getting entity ID from database. It's quite fast operation. And then get any parameter of entity itself. So let me show you how it looks. Reevaluate the function and then, yeah, quite fast query, and we have a set of Datomic entities, and here we can get all the existed attributes of customer name, customer discount type, and so on and so forth, and blah blah blah. So finally, that's the algorithm which is used in production. Here it's implemented to find out the first minimal values after the cursor, but it's not a big deal to generalize it for searching last maximum values before cursor and move forward and backward to calculate the overall amount. For example, the amount of entities which with name more than name 33 is 7,443. Yes, and you can show it here, because in addition to list of minimum n value of cursor, I also calculate a total count of entities which fits this condition. So that's a final implementation, and here you can avoid of lazy queries, avoid of such tricky functions taken sorted by, also avoided a binary search or all that stuff, and it can be generalized in a smart way. You can use cursor not as a string with concatenated maybe name and identifier of entity, yeah. You can make a vector. And also this approach, minimum value of vectors, will sort vectors by their first entities, then if first entities are equal, then second elements, and so on and so on. Yeah, so more complex cursors you can construct here on this algorithm, not only string. So maybe that's up for today's episode. So see you on the next nails. Bye.